So we did transformations actually in chapter 2, where you guys were moving like up, down, left, right, stretch, compress, flip, all of that. We're going to do some more of that today. So you're going to have to call back your knowledge from chapter 2. The first thing that we're going to start off with would be writing quadratic equations in vertex form. All right, so your vertex form looks like this. I just want to get this written in front of you. So y equals a, and then we've got this quantity x minus h squared plus 5. Okay, so when you're looking at this, you can see all the transformations that would be happening. So what this does right here, this is either a stretch or compression. This is a movement either left or right, and remember it's always the opposite of what you think it's going to do. And then this would be a movement up or down, and it does exactly what it looks like it's going to do. So what that means is, since normally quadratic functions start right at the origin, like this is kind of your original quadratic. This is just y equals x squared. If you move h units left or right, and if you move k units up or down, let's say that we've got some sort of new parabola like over here. Okay, so say I shifted it h units left and then shifted it k units down. My vertex would now be at hk. So once it's in this form, it's super, super easy to see what the vertex is. So that's kind of the perk to writing things in vertex form, in case you're wondering. It makes it super easy to graph because you know exactly where the vertex is going to be. So we're going to do a little bit of practice with this. So this first one is a little bit easier because I just have an x squared, and my technique is going to be really, really similar to what I did with completing the square. Okay, so completing the square helps me to write this perfect squared term like this, and then I'll probably have something floating on the end. So I keep my y on the left-hand side, and then I'm going to take these pieces, and I'm going to complete the square on these pieces, just like I did a few sections ago. So I've got this 4, and the 4 isn't the right value. It isn't the number that completes the square. But instead of moving it over here, because I only want y to be by itself on the left-hand side, I'm just gonna kind of move it over. All right, just push it to the side, figure out what I need to complete the square. So I'm gonna focus inside the parentheses for just a moment, and you can see how this is starting to take shape, because this is gonna turn into a perfect square, and then I'm gonna have some sort of number hanging out on the end. All right, so the process works the exact same as it did a few sections ago. You take that middle number in front of the x, you cut it in half, so here I get -1, and then you take that number and square it. Okay, so that gives us 1. So I'm going to add 1 right here. So 1 completes the square. So remember I told you that we're not going to do anything to the y on this side. So normally if I added 1 to the right, I'd add 1 to the left and keep the balance. I'm going to do things a little bit differently because I need to stay all on the right-hand side here. So to keep the balance, what I do is I add 1, and I balance it by subtracting 1. So that's how it's going to work when we're in this section. So now let me rewrite. I've got y equals. I can write this just the same way as I have in the previous sections. I can write this as x minus 1 quantity squared, and then simplify this up. So this is plus 3. So this is my equation rewritten into vertex form. Okay, so my equation for this, my vertex for this would be +1, -3. Because when I am in this form, the x value of my vertex is h, and this is always going to be x minus h, and the y value of the vertex will be k. So just a fun fact, we'll be using this in the next video. The vertex is +1, +3, because this is always opposite of what it looks like, and this is exactly what it looks like. Okay, let's do this one here. Y equals, I keep my quadratic term, I keep my linear term. Rather than moving this over to the left-hand side, I'm just going to push it out of the way. Okay, so now I want to take this right here and I want to complete the square on it. So think back to your completing the square. What we're going to do is we're going to factor this out, because remember I cannot have something in front of the x squared. So this step is super, super important. I cannot have anything in front of the x squared, so I'm going to factor it out. This is a similar step to dividing both sides, but again, I'm not touching this y. So it's kind of like an analogous idea here. Rather than dividing both sides by the -3, I'm just going to factor it out. So I'd be left with an x squared. If I take -18x and factor out a -3, I'd be left with a +6x. Okay, leave some space because I still haven't figured out what number is going to complete the square. Okay, so now I do the same step that I did up here. I have 6, and I'm going to cut it in half. That gives me 3. and then I take 3 and I square it, and that gives me 9. Okay, so 9 is my magic number that completes the square here. Remember though, I can't just add 9 where there didn't used to be a 9 before. Okay, here's the tricky thing with this one, the one that has a -3 on the outside. This isn't really a 9. Looks like a 9, acts like a 9. However, if I were to redistribute this -3, I would have -3x squared, -18x, all what I have up here, -27. So again, while it looks like I added a 9, what I actually added to my equation that I didn't have before was a -27. So I keep the balance by adding 27. Okay, so again, what I really added was a -27, so I balance it out by adding a +27. Okay, so now let's clean this up. So y equals, I have a -3 on the outside. This I can factor down to x plus 3 quantity squared, and then this is going to be a 37 on the outside. So that is my equation in vertex form. The vertex of this, remember x is opposite of what it looks like, so -3, and then the y value is exactly what it looks like. And if we were going to graph this, this would be upside down and stretched. Okay, so I think, yeah, we've got one more for this video. Okay, so we can do some equation writing with this. So if you know the vertex and one additional point, it's going to look something like this. So let me write my equation first. Okay, so if we know the vertex, this -1 and -2, those are the vertex. That's going in for h and going in for k. And then I have an additional point. And my additional point, -4, +13, this is like a sample xy. So the -4 can go in as a sample x, and then the +13 can go in as a sample y. So I'm going to plug all 4 of these values into this equation. And then what I'll be able to solve for is a. So y, my y value is 13. I don't know a, I'm trying to find it. X is -4 minus h, which is -1, so minus -1 squared, plus k, so plus a -2 or -2. Okay, so all I'm going to do is I'm going to clean this up, solve for a, and then resubstitute everything back into the equation. So I can add this 2 to both sides. I get 15 equals a times -4 plus 1 is -3. -3 squared is 9. So divide both sides by 9 and I will get a. So I can reduce this down by 3 and I get 5/3. So I know that a is 5/3, so it's not this one. And it's not this one. And I'm hoping it's this one, because it's not this one. And you can check your vertex is -1, -2. So this is -1, because remember it's the opposite of what it looks like, and then -2. So that would be your answer.